In a previous video on this channel, I went through an introduction to Artillery, an open source testing tool for running load tests on your applications. In that video, I went through the basics of creating simple load tests for checking the performance and resiliency of your APIs. Running your load tests from your local development machine can help you spot obvious performance issues and fix them quickly. But what if you want to really test the limits of your application and your infrastructure? You can send hundreds or thousands of simultaneous requests as part of your testing, but chances are you'll be restricted by resource limitations on your local system. With Artillery, you won't have to worry about that at all. In this video, I'll show you how to go even further with your load testing by running these tests at scale on AWS. Artillery has everything you need built into the tool itself, so you don't need to mess with plugins or separate services. All you need is Artillery and an AWS account. Artillery runs tests on the cloud through Lambda functions or ECS Fargate tasks. We'll go through both of these so you can see how simple it is to run load testing at scale. Let's get to it. In this video, I'll use the airport gap application that I used in my previous video to run my Artillery load tests. If you're new to Artillery and want to see how it works, go check out that video before diving into this one. For the example I'll use here, I already have a load test that goes through a couple of the most common flows used in the API. This load test has two phases. The first one is a gentle warm-up phase that starts at 1 virtual user and ramps up to 10 virtual users in 30 seconds. After that, it'll run a steady flow of 20 concurrent virtual users every second for the next 5 minutes. The test also loads a CSV file containing a list of test account emails and passwords to use during the test. For the scenarios, we'll have two flows. The first flow hits an endpoint to fetch a random page of airports and captures 2 random entries, and then hits a second endpoint to calculate the distance between those 2 airports. The second flow logs in as one of the users defined in the CSV file to capture their authentication token, which we'll then use to fetch their favorite airports. I'll run this test locally using Artillery run loadtest.yaml to see it in action. So after about 5.5 minutes, the test has completed and we can see the results for the test here. We could see that the test created 6,330 virtual users and looks like they all passed. And we can see the different metrics, the minimum, maximum, and the 95th, 99th percentile. So we can see that everything is running well. Now, I can bump up the number of virtual users to send to the API or increase the length of the test if I want to stretch the limits of the system where the API is running. But simulating thousands of virtual users is pretty demanding on your hardware, and you'll need plenty of bandwidth to sustain throughout the whole test run if you want consistent results. Instead of finding more powerful hardware or hoping that I have enough stable bandwidth, a better solution is to offload these tests to the cloud. Artillery allows you to run your load tests on AWS Lambda or ECS Fargate right from your terminal, in most cases without having to modify the test scripts at all. Let's see how this works. However, before we get into it, we need to make sure our system has the correct permissions to let Artillery set up the resources it needs on our AWS account. Artillery uses the AWS SDK to create the resources it needs to run load tests on your AWS account. You need to ensure that the system running the tests is configured to access AWS resources through the command line. You can do this in a few ways, like setting environment variables or creating a credentials file on your system. The AWS documentation explains this process in detail, so if you're setting up AWS for the first time, you'll need to configure your system before running your tests with Artillery. You'll also need to make sure the AWS profile you configure on your system has the correct permissions to create the resources Artillery needs to run your tests. The easiest way is to use an IAM user with the administrator access policy assigned to it, which grants it permission to create just about anything on an AWS account. However, it's best to apply the principle of least privilege, meaning that the IAM user should have the fewest permissions needed to accomplish a given task. The Artillery documentation has an example policy you can set up on your AWS account and apply it to the IAM user for your configured profile. Artillery also has a cloud formation stack available that can automatically provision a policy and a role by clicking the Launch Stack button on the documentation, so you don't need to set it up manually. For this video, I already have the AWS command line tool set up on this system and configured with a profile that has the necessary permissions, so I won't go through the process here. With the system configured, let's run these tests on AWS Lambda. Before I run the tests, I want to increase the number of concurrent virtual users so we can see what Artillery is capable of when running these tests on AWS. I'll keep the warm-up phase as it is, but change the number of virtual users for the next phase from 20 to 1,000, just to see how our systems react. Instead of using Artillery run as we did to run the tests locally, the command to run the tests on Lambda is Artillery run Lambda. We need to specify the region using the region flag and setting the name of the AWS region where you want to set up the resources and run the Lambda function. Since the server I want to test is located in the west coast of the United States, I'll choose the US West 2 region. After choosing the region, all I need to tell Artillery is which test script I want to use. So I'll use the one that I have for this example, which is load test.yaml. This is all you need to have Artillery run your tests on the cloud. We don't need to modify the test script or install any additional plugins or tools for this, so it's really straightforward. When you run this command, Artillery will check if your configured AWS account has the resources it needs and creates them if needed. It then prepares a Lambda function and uploads a bundle containing the files for your load test. In this example, it's uploading the test script, and it also automatically includes the payload file that I specified in the load test itself, which is very convenient. The first time you run this command, it'll take a minute or two while Artillery creates the resources on AWS before it starts to run the tests. After a short while, Artillery begins running the load test on Lambda and showing metrics every 10 seconds, just as if you were running the test locally. When the test is done, you'll see similar results as when running the tests locally. It also shows you an estimated cost for running this test on Lambda, so you can have an idea of how much one of these test runs will cost. Typically, they'll just be a few pennies or less, so unless you're running a very large-scale load test, running these tests on Lambda won't cost you much. When I ran this test, the only thing I set was the region, which is the only required flag for the run Lambda command. Artillery will set a few defaults that you likely won't need to change, but are good to know about in case you want to tweak how your load test will run. By default, Artillery will run your load test on a Lambda function powered by AWS's Graviton processors, which is an ARM-based processor. It's a good default because Lambda functions running on Graviton can offer better performance at a lower cost. If you need or prefer to use an x86 powered Lambda function, the architecture flag allows you to change the setting with a value of x86 64. Something else you might want to tweak is the memory size of the Lambda function. Artillery sets the memory size of the Lambda function to 4096 megabytes by default. You can adjust this setting by using the memory size flag. For instance, if you want to set the memory size of the Lambda function to 8192 megabytes, then you could set the memory size flag and set the number of megabytes. You can also adjust how many load generators you want to spin up on Lambda. The run Lambda command runs your tests on a single Lambda function. However, if you want to run simultaneous load tests, using the count flag will tell Artillery to run the load test on multiple Lambda functions. So for instance, if you set the count to 3, it'll run your load test on 3 simultaneous Lambda functions, meaning your systems will receive 3 times the requests. If you really want to test the limits of your system, this is a great way to do it. The run Lambda command has a few additional flags that you can use to change how Artillery runs your load tests on Lambda. So check out the documentation for more details. While it's pretty easy to run your Artillery load test on AWS Lambda, there are a few limitations that you need to be aware of. Because Lambda functions have a maximum function timeout of 15 minutes, you need to make sure that your load tests finish within that time period. Otherwise, you'll receive incomplete test results. Also, once Artillery launches the load test in Lambda, there is no way to interrupt the test. So be careful about where you're targeting your load tests because once it starts, you'll have to wait until it finishes. Another thing to keep in mind is that some artillery features work differently or aren't available when running your tests on Lambda. Now that we've seen how artillery runs your tests on AWS Lambda, let's see how they run on ECS Fargate. Running your artillery tests on Fargate works similar to running them on Lambda, but without the limitations I just mentioned. The main reason for choosing Fargate is that it has no time restrictions when running a task. So if you need to run an artillery load test for over 15 minutes, you'll need to use Fargate. You'll also have more control over certain aspects, like additional CPU and memory capacity, running on cheaper spot instances, and more. The command to run artillery on Fargate is almost identical to running them on Lambda. Instead of run Lambda, we'll use run Fargate. We'll also need to specify the region as we did before with the region flag, and I'll use the same, which is US West 2, and specify the test script, which is loadtest.yaml. There are no additional modifications needed, just as when running the test with Lambda. Running this command will create an ECS cluster on your AWS account and launch a task in the cluster to run the load tests. It'll begin showing metrics as usual, including a few additional metrics that don't show up when running the test locally or on Lambda. Just as before, you'll be able to see the results of the test run when it finishes. Unlike running the test on Lambda though, we won't see a cost estimate at the end. However, the pricing should be similar depending on the use case, so running your load tests on ECS is still a very cost-effective solution. As we can see here, we have a couple of additional metrics thanks to a plugin that's loaded automatically when running the tests on Fargate. And we can see that our test created more than 6,000 virtual users, and it looks like nothing failed. So everything looks fine. The maximum is a little bit high, but everything else is looking pretty well. So we could expand this test if we wanted and just run it with more users, and ECS Fargate or Lambda for that matter would not break a sweat. As with running the test on Lambda, using the run Fargate command also sets a few default settings you may want to adjust. As mentioned earlier, artillery will create an ECS cluster for launching tasks on Fargate. If you have an existing cluster that you would prefer to use, you can set it with the cluster flag and specify the name of your desired cluster. Also, the tasks used to run the load tests are set to use 4 vCPUs and 8 GB of memory. If you need to increase the capacity for the tasks, use the CPU and memory flags as needed. For example, if I want to use 8 vCPUs, I'll just set the CPU flag to 8. And if I want to use 16 GB of memory, I could just set the memory flag to 16. Artillery also launches one task to run your load test by default. You can increase the number of concurrent tasks by setting the count flag, so you can generate additional load during your test, similar to how the same flag works on Lambda. The run Fargate command has lots more additional flags to change how artillery runs your load tests on ECS, so make sure to check out the documentation to learn more and see a few useful examples of other ways to launch these tests on Fargate. If you need to run load tests at scale, you can't go wrong with artillery. With its built-in support to run load tests on AWS Lambda or ECS Fargate without any extra work, you'll be up and running in no time compared with other load testing tools. For most artillery load tests that run in under 15 minutes, running them on Lambda will be more than enough. For longer tests, you have the option to run them without time restrictions on ECS Fargate. You can also use Fargate if you need additional computing capacity or to run your tests on spot instances to save on some cache. Whichever option you choose, you have what you need to hit your performance goals. If you found this video helpful, consider subscribing to this channel for more tips on helping developers ship their code confidently, from development to deployment. You can also check my website for more in-depth articles covering Rails, testing, DevOps, and other software engineering topics. Thanks for watching, and I'll see you in the next video.